So in this lecture series, we'll study about the relation between the standard deviation that you have studied in your statistics and the uncertainty principle in quantum mechanics. Okay, let me remind you about the uncertainty principle. The uncertainty principle in quantum mechanics stated that the uncertainty in position when multiplied with the uncertainty in momentum. Okay, so the product of these two uncertainty is always greater than h cross by 2. Agreed. So this was uncertainty principle. Now in the lecture, however, in the uncertainty lecture, I stated the uncertainty as this. So if you are conducting a electron diffraction experiment, then this this one is the uncertainty, that is the width of the slit is actually the uncertainty of the position. This one I have explained in the lecture. So in our uncertainty lecture, what we have done is the uncertainty in position was d, and then there was an uncertainty in momentum. So there was an uncertainty in momentum in the y direction. Okay, and we proved that multiplication of these two was greater than h cross by 2. Okay, although we got h there, but anyhow it is taken h cross by 2. That is a concrete proof, and this is just a rough proof. Now this example is easy to see. Okay, so this one is easy to see, and one can easily predict the uncertainty in position. Agreed. However, there is another way to calculate the uncertainty in position. So the calculation of uncertainty in position is not that so easy. Okay, for example, let me give you another example. So consider you are given only a screen, and say you have detectors as discrete positions. So consider a detector here. Okay, consider another detector here. So another detector here, and so on. So detector 1 says at position xi, x1. The detector 2 is at position say x2. The detector 3 is at position say x3. Okay, and so on. Now you know with what probability the electron is hitting x1. You know with say the probability is p1. So the probability of getting an electron at x1 detector is p1. Similarly, the probability of getting an electron in x2 position or x2 detector is p2, and the probability of getting electron at x3 position or the detector at x3 is p3. Then how you calculated the expectation value? So you calculated the expectation value. So see, this is a discrete example. So you calculated the expectation value as summation I. Okay, so the probability at each xi multiplied with all the xi's. Okay, so this is what we have done in our last lecture. That is, we stated that this is the expectation value of x. But this trick just gave you the expectation value. Now question is, what is then the uncertainty in x? Okay, if this is the expectation value, then what is the uncertainty in the position? Okay, so now what we will do is we will use this data. Okay, we will use this data to find the uncertainty in the position. So we'll do this in this lecture series. So before explaining this, let us little bit understand about what do you mean by standard deviation. Okay, let us go to statistics a bit. Now consider you are given uh, say marks of students. Okay, so consider you are given marks of students. So consider there are n students. So how many students are there? So there are n number of students. Okay, and the n number of students have secured a mark. Say the first student has got a mark m1, the second student has got a mark m2, and so on. Agreed. Now, how do you calculate the expectation value, the average mark, not the expectation value? How do you calculate the average mark? Say the average mark is represented by M. Okay. This is actually the expectation value itself. Okay. So, um, or this is also represented as, so what is the average mark M? Okay. So how do you calculate the average? You just add all the marks. So the mark of student 1 added with mark of student 2 and so on. And since there are n student, so you add the mark till the nth student. Okay. And you divide it by n. So you know how to calculate the average. Okay. So what is the symbolism? So these things are written as summation I. Okay, so I is going from what? I is going from 1 to n, since there are n number of students, and you write m I. Agreed? And you divided n, so write 1 by n this side. Okay, so this is your average value. Okay, this is your average value. Now, so then there is another definition in statistics called as the standard deviation. Okay, so let me write the definition and then I'll explain. So it is represented by sigma, and sigma is calculated as follows. So it is root over of, okay, 1 by n. So it is 1 by n. Okay, so n is the number of values given. Okay, let it be marks or whatever. Summation I. Okay, and then you have this mi, that is individual marks of student. So mi is what? Individual marks of students, minus then you'll this is the average mark. M bar is the average mark, and this quantity is needed to be squared, and all the quantity, everything is inside the square root. Agreed? Now question is, what is standard deviation? So what is standard deviation and how to calculate the standard deviation? So let us see what is standard deviation. Let me give an example. As you can see below, so consider marks of 4 students here. Agreed. So consider student number A. So student A, say he has secured a mark 3. Okay. And there is student B, there is student C, and say there is a student D. So B will get a mark, say 6. C has got a mark 7. So all these marks are out of 10, and D has got a mark 8. Agreed? So all these marks are out of 10. Now, can you tell me what is the average of this system? So this system has marks of 4 students. So how do you calculate the average? So the average is sum of marks of all the 4 students. So you'll do 3 plus 8 plus 7 plus 6, okay, divided by 4. So we have added marks of all 4 students divided by 4, and we find that the average value is somewhere around 6, amazingly. Okay, now can you tell me now what is 6? 6 is the average value. Agreed? Average value of all the marks. Okay, now can you tell me A has got a mark 3, so how much A is away from the average? So mi means mark of A, m bar means average of the class. So the class of 4 students. So mark of A is 3, okay, and the average of the class is 6. So by how much mark is A's mark deviated from average? That will be minus 3. Okay. Now similarly, by how much mark B's mark is deviated from average? Now B's mark is exactly at the average. So there is no deviation. Third, the deviation is 1, and fourth, the deviation is 2. Now to eliminate the minus sign, what we do is we square them. The square is only to eliminate the minus sign. So it's 9, 0, 1 and 4. Okay. So what does this thing measure? So this thing actually measures the deviation from the average mark. Okay, it measures the deviation from the average marks. And then what you do is you just add all of them. Okay, you just add all of them and you divide it by 4. Okay, so what you get sigma. Okay, uh, what is sigma? So you need to do root over of, so what is 1 by n? So the number of students are 4. Okay, and then you need to add all this, so 9 plus 0 plus 1, so that becomes, I guess, 14. Okay, and then you'll get some number. Okay, some number you'll get. So what is actually sigma? Now sigma is actually measuring the standard deviation. Okay, in other words, sigma gives the values that says how in this system marks are deviated. Agreed? Sigma gives the idea how in this system of 4 students the marks are deviated from the average. Okay, so sigma gives a spread. Agreed? Sigma gives a spread. So this is what statistical mechanics says. Now, if we go to quantum mechanics, then mathematicians and physicists both agree to the fact that the standard deviation sigma can be used as a measure of uncertainty. This is a quite interesting thing, that the standard deviation sigma can be used as a measure of uncertainty. After all, uncertainty is the spread in various possible values of position. Agreed? So for example, if you are measuring the uncertainty in position, then what do you mean by uncertainty in position? It means the spread in all the values of position. That's the uncertainty. Agreed? How the values of x have got spreaded in the entire system. So what are the possible values of x? So the spread in their values is actually the uncertainty. Agreed? So in the next lecture, we'll look at the uncertainty in more, the standard deviation and the uncertainty in more detail.